Monday, December 13th. I'm Rim.
I'm Scott.
And this is Geeknights. Tonight, in the year of our Lord 2010, we talk about Abstraction.
Let's do this. So apparently Rim tells me that he is illicitly modifying the shows of Geeknights.
What evidence have you?
You just said so.
When? Prove it.
A minute ago.
If I go back to the audio record, it appears that a minute ago, there is no audio.
Well, you know, I could just go and get any of the MP3s and I could listen to them until I hear...
Oh shit, the Marantz was on. I gotta delete that.
Until I hear some illicit edits that you may have made. So, if anyone, you know, if you are misjudging, you may be misjudging Rim falsely positively and misjudging me falsely negatively.
What kind of edit do you think I could have made? It's not like I can really add words that you said.
You could cut out, you know, I've said pretty much almost every word in my vocabulary through the course of this show, so you could cut and paste them together to make me say pretty much anything.
That'd be way too much effort.
I'm just saying, you admitted to illicitly adding things to the show.
One, you have no evidence of that. And two...
You just said you did. It's on the Marantz.
And two, the last time I did that was when you were chewing that
you just admitted that you're going to do it.
When you were chewing that goddamn gum. I edited out like 2 minutes of you gum smacking.
Well, come on.
I replaced it with me saying Scott was chewing gum for 2 minutes.
Yeah, don't do that.
Nah?
No.
Nah?
Anyway.
Maybe if you learn audition and audio engineering, you could take this over.
It's not. I just wouldn't care.
I'll just send you. I'll just send you the raw wave, and then you can edit it together.
I'll just turn it into MP3 and upload.
Or with like 5 minutes of us arguing about what the show's going to be on.
Yeah. Because then people will see the truth.
You know,
the unedited truth.
We said we were going to do that a long time ago, and we never did. Do one special show where we just record the whole conversation before and after the show, and then like. We put up that week the show, and then the next week we put up the making of.
Yeah, there's not much making of.
Just now there was.
Not really.
Apparently. You have all these accusations, wild accusations.
That you just admitted to. You confessed.
Oh, because you think I'm not going to edit that out?
You confessed to the comfy chair.
You realize I could edit this whole thing out. I could start the show right now.
Yeah, anyway. So, you know, I got all kinds of Arduino and electronic stuff, and I never really... You know, like I did a whole bunch of just, you know, follow the instructions kind of things to make stuff, but I didn't really make anything on my own initiative because I didn't really have an idea.
It's kind of like when I learned to cut, like I had to learn C# to do web service at work. So I made kind of half of a program because I thought, oh, I'll make my own, like I'll make a shitty little ticketing system just to learn. And I got, I don't know, a day into that and I just stopped.
Yeah, so... but I actually have something I want to make, and I'm going to make it. And the thing that's good about it is it's mostly crafty, right? The actual electronic part is like 5 minutes almost, right? So here's what I'm going to make. Ready? Remember that thing, the shocking roulette? You put your finger in it, and it'll go...
Oh, we thought about buying that at RIT to decide who goes first in Puerto Rico.
Well, that's the point of it, right? But I got a better idea. I'm going to make pretty much the...
Same thing with an airsoft gun?
That's a good idea, too.
Same thing with rat traps?
That's not a bad idea, either. I'm going to make, basically, as small as possible, the ultimate board game gadget, right? And what it's going to do is going to do many things that you need in board games.
All I need is a turn-taker timer.
Okay, it's going to have turn-taking timing with chess turn-taking timing mode.
For multiplayer, too? Like 8 players?
Oh, it's going to have a lot of players. Tons, right? It's going to have... choose a player at random for whatever you might need to do that, you know, going first, turn, you know, all kinds of stuff, right? It's gonna have, I forget the other things I was gonna have.
Not much else, apparently.
Oh, it's gonna have, like, money counting for games where you don't want to use the stupid paper money. You can actually have money for each person, right?
So this is just software, then? What do you need the Arduino for?
Well, because it'll be a nice little... It won't be just like a computer program on your, you know, laptop.
I mean, what? Am I going to put it on the money counter in Monopoly so when I pull a 500 out, it says Rim has taken 500 Monopoly dollars?
They'll just be like, you know, up and down. You know.
I mean, you could do... I mean, I used to do that when as a kid. I'd always sit there with my calculator, and I would do all my money, and everyone else...
That's how I would do it, too.
And then everyone else would accuse me of cheating.
Yeah. There was one other thing I was going to have. Turn time taking, choose player at random.
Shocking.
No shocking.
Why not? The shocking's all I wanted. I didn't care about the random. I could roll a freaking...
Quiz bowl buzzing in. Like deep.
Because independently, I was actually thinking about I thought about making one, and then I saw that they're so cheap If
think
it
about
took-
it, you could read like the same LEDs that will, like, one of them will light up to say who, choose player at random. You could use those same ones for who buzzed first, so it's you get a lot of reuse going on. And they can make it just nice, small, little compact thing. So you keep it in your bag, and when you go to play a board game, you just put it in the middle of the table, and it's just got a little 16:2 LCD screen and a bunch of LEDs and some buttons.
See, I was thinking about making just the Quiz Bowl thing because I knew how to make them. I helped people make them for my high school all the time because we couldn't afford to buy the fancy ones, so we'd make,
No, but this will be money saving, right? Because you don't need any more electronics to add these extra purposes. You have the same number of buttons and the same number of LEDs, but you just add extra software and you get more functionality out of the same hardware.
You really need the shocking, though.
The shocking requires extra hardware.
Yeah, just mount a taser on it. It spins in a circle and shoots randomly.
Well, that's all you. I'm going to do LEDs.
You ever put your finger in that shocking thing? It actually kind of hurts.
I've done the one where you have the metal twisted wire, and you get the hoop, and you try to guide the hoop along the wire without touching the wire with the hoop. And you put your finger on a thing, and if you mess up, it will shock you. Well, if your fingers are also on the shocking pad. I've done that.
I could see this being useful, but the reason I didn't actually make one was that it's cheaper to buy one if I count. Even if it takes me like a half hour to make it, it's cheaper to just buy one.
Buy what?
A Quiz Bowl buzzer
How
by
much
itself.
are they?
Like $40.
Oh, Arduino. And one Arduino is $30, so it's pretty close.
Yeah.
Yeah.
Plus, it depends. I mean,
but the thing is,
you can get the fancy Quiz Bowl ones that have like the different lights for teams, multi-team interaction, networking them across rooms.
Yeah, I'm gonna have to go and try to. The thing is, I have to scavenge up like some good buttons that are good for hitting. I'm thinking I might get that thing from Staples. What's that? The red.
Oh, the easy button.
Yeah.
You can get better buttons.
I need a good button though that's good that you can hit hard and frequently.
I'll show you some places to get buttons. This sounds dumb. I actually do have good knowledge on buttons specifically. You want to know why?
Mm-hmm.
Remember when I made that hard DDR pad?
Yeah. Well, I need something that you can punch with your fist and has a nice cable on it.
Yeah, I did a lot of research into switches and buttons.
All right.
And ribbon switches are actually what you want if you want to make a DDR pad.
And then what I'm
They're
making
just
a DDR pad.
It's just a long ribbon, and if you squeeze it anywhere, it goes off.
Uh-huh.
Yeah.
All right.
All right. So the news apparently is Gawker, which is something I mostly ignore.
Well, so Gawker, if you don't realize this, right, there's a whole bunch of blogs out in the world. Some of the most popular blogs, actually, are part of this company called Gawker Media, and they're actually in New York. And the company consists of many blogs, such as Gawker, Kotaku, Gizmodo, IO9, and a bunch of other ones that I don't remember.
Yeah, Lifehacker.
Lifehacker, I think.
Apparently, Fleshbot.
Yeah, Fleshbot's the porn blog.
Yes.
It's basically just porn. It's not even really a blog. It doesn't have stories about the porn industry. It just has, hey, check out this porn.
Deadspin is I'm on the Wikipedia page. Jezebel for celebrity sex.
Yeah.
Great.
Basically,
classy company.
Yeah. Anyway, pretty much the only Gawker thing I even pay attention to is Kotaku, and the only reason I prefer Kotaku over Joystick is because I think Joystick is, while it's high quality, Kotaku definitely focuses more on the Japan stuff because they actually have people in Japan. So that helps them. But all the other Gawker blogs I couldn't give a shit about. But anyway, they fucked up, right, at Gawker.
Now you fucked up.
You fucked up. They fucked up big time in the security department of computers. So what happened was somebody, through some probably very easy means, managed to steal everything from Gawker. The source code to their blog software, which I'm pretty sure is just regular old blog software that's slightly modified.
I highly doubt they have anything particularly special.
No, it's just probably a CMS, just like, it's a WordPress kind of thing or movable type or one of those. I don't even know which one they use. And then they stole their entire database for all their blogs, including all the usernames and passwords for posting comments and such.
But of course, they were encrypted.
Yeah, they were. They were indeed. But they made a very big mistake. And this is you can get all the details of this story elsewhere on the internet. But the one thing I really want to focus on is the storing of the passwords in the database, right? Because most of the stories you're going to read on the internet won't discuss this very technical topic in any depth to where you'll actually understand what's going on. But it's a very important topic, and all the other parts of this story are discussed everywhere in great depth. So anyway, here's the way it works, right? I have a website. I want you to log into the website. It means you need to, every time you go to the website, you type in a username and a password, and you push submit. And when you register at the website, you also type in the password, right, to tell me what it is. Now, I can just write down the password in the database. But that means anyone who gets the database can see everyone's password and then log in as anyone.
I have worked at places where I had to change my password in the system and it was old and no one could tell me how. So breaking into the system and looking at the database, I could see everyone's passwords and just do an update statement to set a new password for myself.
Yeah. Well, I mean, if you have access to the actual database server, you can edit any of the passwords easily. But to read the password is a different story, especially since many morons in the world use the same password on every website. So if you get their seemingly innocuous blog comment posting password, you could probably get into their bank account.
Yep, because the email, and then once you get email is like the gateway to everything. It's like the chart at RWAG of who has slept with who.
Yeah.
If you can get to someone's email, you can get to every other thing they've got.
Yeah, and this is the thing, is that most people use the same password everywhere, right? And when you hear stories about like, oh, he hacked a MySpace, he hacked Facebook, usually it's just they had a really shitty password and someone guessed it or saw it or figured it out.
Yep, because passwords in databases are hashed or munged or something.
Right, so here's the part I want to talk about. So we need to fix this. You can't just have a password in the database. It doesn't work. So what the solution is we encrypt the password. But how can if we encrypt the password, then we could just decrypt it, right? If I use a code of like, okay, we're going to take every letter in the password and make it go up by one. So if your password is ABBB, we'll change it to BCCC. And then, right? That doesn't work either, because as soon as someone knows the code, they can reverse the code.
But thankfully in maths, there are one-way transformations.
Right, so we have hashes that are one way. You've probably heard of things like MD5 or SHA1 or DES, right? So you encrypt something, basically, it's a one-way math. So if it's one way, though, how can we get it back and figure out if it's the right password? Well, here's what you do, right? Let's say your password is the letter A, and I pipe it through MD5, and out comes blah, 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 right? So I write blah, 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 blah in the database. So now you come to the website again, and you type in A. I take that A, and I run it through the same, grist mill, and out comes blah, 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 and I can check to see if the blah, blah, blah match, and if they match, then I know that you just typed in the right password, even though I didn't know what the right password was because the right password was not in the database. And also, because of maths that I'm not going to explain, you can't take the blugga blugga.
I want to tell the listeners, because this applies to me as well. Anytime we say math that we don't want to explain, that is code for math that we don't particularly know.
I know it.
By heart?
You can't go backwards, right? So if I just say, here, Rim, here's blugga blugga, tell me what the password is, Rim will have no fucking clue. There's no way for him to know.
Now, what I could do is brute force it.
Yes, and this is actually something that is many, many people have done, because actually it takes less than a fraction of a second to do an MD5 of anything.
Which, as an aside, is why one of the most important things for security is on your outward-facing portals to slow down, to throttle the rate of login attempts as people continue to fail.
Yep.
That is one of the surest ways to
Or
prevent,
to lock out accounts after a certain number of false attempts.
Which means so many work BlackBerries get locked out because people are stupid.
They're stupid.
But
Anyway. Or to have some physical thing like a YubiKey or a RSA secure ID.
So I went to log on to Server Fault the other day to ask a question about DRBD, and it was like, what's your YubiKey? And I was like, oh, fuck, I own a YubiKey.
Yeah.
Where is he?
On your keychain?
I found it, and I plugged it in, and it worked.
Yeah, there you go. It only works 32,000 times. Then I had to give you a new one.
I'm running out.
I know, right? It's very slowly. But anyway...
I think I've used my YubiKey more times to show other people how it works than I've used it to actually log into anything.
That's fine. I can incorporate it into anything we've got.
We should do it on the website, I think.
I could do that. Anyway, I have it on all my WordPress blogs. MD5 is not the greatest idea, because somebody out there, and many people have done this, is they just get the MD5 of everything. They go, all right, what's the MD5 of A? And they write it down. What's the MD5 of B? And they write it down. What's the MD5 of C? And they write it down.
Yeah, so if I look in your database and I find herptederptabar in the password hash, and I know that herptederptabar is what happens when I put welcome into the text prompt.
Yeah, basically, people have these thing called rainbow tables, and they've written down, you can just download these things, the vast majority of the most common passwords, MD5 hashed. So they can just, if they have the MD5 hash, even though it's not reversible math, they've done the one-way math for almost every possible password. So they just look up what your password is in this big old list of passwords.
It's kind of like when you do complex integrations, where sometimes there is no, or like complex factoring, where there is no procedure that is guaranteed to work that a human can follow. I mean, computers can follow, PNP. They can follow algorithms that'll eventually guaranteed find an answer. But humans don't have that luxury, and a lot of times the way to solve an integral is to look up how to solve it because someone else already figured out the optimal path.
Right. Now, there are some things that you can do to help this. For example, some people use salts, and what a salt is okay, instead of just running your password on its own through the one-way math, we're going to take your password and also your username and the date that you joined this website and put them all together and then run that through the one-way math. And that helps quite a bit, right? Because now someone, can't just sit there guessing passwords. They also have to guess, the time you joined, and they have to know that that's what the salt is in order to actually get the password. It becomes a little bit more difficult.
Yep. Or they have to pull some sort of Tycho Brahe math where they figure it out indirectly, which is not likely. That is solving that.
Well, I mean, the thing is, in this case, it wouldn't have helped because they have access to the database and the source code of the Gawker website, so they know what the salt is because they can see the salt right in the source code of the website.
Oh, snap.
So with that knowledge, and with, the thing is, Gawker wasn't even using a salt. They were just using straight up DES, right?
Oh, snap.
So they can see the source code and they have the hashed password, so they can figure out everything. They just have to go and they just have to get their tables, and they can, because DES is pretty fast to calculate, they can just, if they don't have a table already, they just generate a new table, and it's going to take them a few days.
They try to cover it up, but it's too late.
Right.
I've seen everything.
So what is the solution to this problem? Well, you might be thinking, well, Rim and Scott are always talking about public key, private key. Isn't that the right solution? No, that actually doesn't work at all for this.
Yeah.
What are you going to do? Okay, so I'll encrypt my password with my private key and send it to you. Okay, yeah, that fails. Okay, so I'll encrypt my password with your public key and send it, and there's no way to do it,
You
right?
could use a public-private key system of key exchange that lets you log into the site, but then isn't you?
Well, that's SSL. Okay, so I the login to the site is SSL, so nobody can just sniff my password off the network. But you still have to store something in your database that you can decrypt to verify that the password that I have sent to you is the correct password.
Kind of like a lot of people carry their private keys around on a USB stick. That's well and good unless someone has access to your USB stick for 2 seconds.
You could do an SSH model where basically instead of giving you a password, I give you my public key and you store that in your database, and then I log into the website with a challenge response because I have my private key on my computer. That's far too difficult, and no one will ever be able to do that.
You do that for things like government secrets that, WikiLeaks doesn't matter.
Your servers with SSH. That's
yeah.
all right? That's not going to work for logging into websites. Just like YubiKey and RSA Secure ID aren't really going to work for logging into websites. People can barely handle, WoW and PayPal using physical login mechanisms. They're not going to be able to handle it for every single website in the world. So the correct solution, at least as of right now, is actually a thing called bcrypt. And bcrypt isn't really mathematically much different than using, hashes on a salt, with a one-way math. The one thing that bcrypt actually has an advantage of, though, however, is that it's actually kind of slow, right? You can still generate a rainbow table for bcrypt, but it'll take you a fucking long-ass time. And you might be saying, well, so as soon as we wait a couple years, bcrypt will be dead because I'll just use a faster computer, and that'll be that, right? I can figure out all the bcrypts. Well, bcrypt actually has options where you can tell it how long you want it to take. So it can actually, as computers get faster, you can just keep changing the number that you're telling bcrypt, right, to go slower and slower until basically you can always make it so that it takes like 5 minutes to, even if you make it take 2 seconds to generate the password with bcrypt, right? And you keep changing it as computers get faster so that it always takes 2 seconds. That's still 2 seconds times the number of passwords. It's going to take them centuries.
Because remember, it's not the number of passwords until they get yours. That's just even to generate the tables, like if you're going to brute force it.
Yeah, they had, remember, this is one-way math. They can't just take it and, look up and go backwards from the encrypted stuff to get the password. They actually have to try every password in the universe until they find a match for, what you've got.
Think of it as like a CAPTCHA system for computers. We've got a human who wants to connect, and say you give them increasingly difficult to solve mathematical CAPTCHAs as they continue to fail to log on. So it takes more actual, real entropy, universe-destroying effort to get in, to make one more attempt.
Yep. So if you're worried about your database being taken from your website, right, and you actually have, if you're just using software that someone else wrote, like WordPress or something, just let it be. Don't, worry too much about it. Just keep it up to date with the security, fixes.
2,650 users in their database were using the password either password or QWERTY.
Yeah. I mean, our, my WordPress blogs, I added YubiKey to them because I know WordPress frequently has security holes, and I'm always updating it to make sure. But I haven't really changed. It still uses whatever WordPress uses for encrypting passwords, But if I make my own site, right, I'm doing the bcrypt and the salt and the whole, right? I'm going full on to make sure that shit is working. And
What's
also
cool,
maybe YubiKey.
As an aside, Salt does it, this is just one very specific application of Salt. I don't know if Firefox still does it, but back in the day, Mozilla too, your profile directories would be, your username and then a dot and then a bunch of random characters so that worms and things that might try to exploit profiles couldn't easily figure out what your profile was based on when you logged in or anything.
They could just go into the profile folder and see that there's only one folder in there, and that would be the only folder in there.
Yeah, it was used. This is a primitive mechanism from 2002.
Yeah. Anyway, but you see, this is how you have to store passwords in databases to let people log in without giving all the passwords away, right? And this is why you should never, when Steam or when any of those other people tell you, don't tell anyone your password, even the company that you are, working with. Don't even tell your password to your bank because the bank doesn't know the password. They've just got a database full of gobbledygook, right? So there's no reason to ever tell anyone in the universe your password ever because they don't need to know it in their database, right? And no one else needs to know it. Only you need to know it. So don't tell anyone because of this stuff that we are saying right now.
So I'll talk about this briefly because we went on for a while about the other thing.
To make sure people understood this very important personal security information.
But it looks like good things are on the horizon. There's an article on Slashdot talking about this, but we might slowly see the end of VGA.
VGA cables?
Yeah.
They're not... they're already dead. What's the...
Pretty much every projector in the business and convention world has just a VGA input.
Well, no. Most of the projectors that I've seen in recent history have all kinds of inputs. The thing is, people always use VGA because the least common denominator. And even if someone has DVI or HDMI or DisplayPort output, it can always be converted to VGA. So rather than provide a litany of different cables for different occasions and different laptops, they always just give you a VGA. And then no
Mac
matter
users
what,
are completely fail at every convention.
Well, because they forget to bring their adapters, right?
If they even have it.
Yeah, but you can just go and they have the adapters, they exist. So it's just the fact that it's the least common denominator. That's the only reason it's still around on the projectors. It doesn't really need to be. We could probably provide DVI and start giving to the finger to the few people who have only VGA as their option. But the problem is,
but at the same time, laptop. My laptop's VGA only.
Really? Mine has VGA output, but it also has some other options.
What other options does it have?
Let me take a look.
It might have a display port, which is starting to be more common.
No, I guess it doesn't have any. I thought I had another option.
Nah. So we got the DVI only projector. Now what?
Oh no, actually, it does have a different option, but I need the docking. Station.
So you're gonna bring your docking station to do a presentation at a convention?
I don't have a docking station. But, I've seen plenty of laptops, most of them nowadays, the newer ones have DisplayPort or HDMI or...
Not as many as you'd think, though. The higher end ones
DVI.
Mini DVI is around more, but VGA is still pretty much the standard on projectors. Mostly, I think the biggest reason why we haven't been able to just kind of chuck it as quickly as we have other things is that VGA has such a long history, and a lot of people are really cheap.
The other
old
thing
projectors
is
that they're not replacing.
The other thing is, right? Take for example, my TV was stolen, right? They also stole my HDMI cable, so I had to buy some new ones. When I got a new TV before I was able to get new HDMI cable. So for a day or two, I plugged in my HTPC to my new TV with a VGA cable. You know what? It was at 1080p full HD on a VGA cable just fine. I really couldn't tell a difference between the HDMI cable and the VGA cable, other than the fact that the video driver was a little flaky using I had to set it differently.
Yep.
And I had to push the auto sync button. And also, it doesn't send audio over the VGA cable. But other than that, the actual video quality after I got it aligned was identical.
Yeah, but it's a little, because I was playing around plugging my computer and different things in with HDMI versus the VGA. And the VGA, for some reason, it's a little fuzzy.
I didn't notice
And
any
there's some
fuzziness.
overscan.
I mean, it's LCD. You can't really.
Yeah.
Well, I had underscan with the HDMI, but then I fixed it because the ATI driver sucked. Yeah, that's right, ATI driver, you suck.
But basically, Intel is taking the first step, and by 2015, they're going to stop supporting VGA in all of their client processors and chipsets.
No, good idea.
Yeah. I mean, this is...
It doesn't matter, though, because, okay, we'll stop supporting VGA, so everyone will have DVI with adapters.
Yeah.
What really needs to happen is we just need to be like, you need to, when you go to a place, right, you do the slow transition, instead of just having a VGA cable be the only thing, when you hook up a projector at a conference or in a conference room, have a DVI cable there also. Have an HDMI cable there also.
Well,
have these other cables next to the VGA cable. So
that is why I wanted to bring this article up, because if you look at the trend of computing and technology history, very rarely has the non-backward compatible kind of long change thing been the one that failed when there's a race.
Mm-hmm.
And in this case, look at most projectors now. I said they all have VGA. Usually they also have S-Video and RCA.
Yeah, it's because they're not expecting computers. Most of them are not meant for computers primarily, even though that's what they're used for primarily.
But all the old computers, like old laptops I had at work, they all have S-Video out.
Some of them, the old ones. Yeah.
So basically what's going to happen is it's kind of like we've got this queue, and now we're dropping RCA and S-Video off the end, and VGA is going to be the old-ass connector on everything, but new things coming out are slowly probably going to have, like, DisplayPort and VGA.
I think really what we need to have is we need to have HDMI because, right, the HDMI also has audio. So as soon as people can realize that and it actually starts to work well, if you hook up your laptop with HDMI and the audio also works, right, and the video on the projector without having to have the separate tiny little wire for your headphone hole.
However, it is annoying to me personally, only because when I'm, at running conventions and doing things like that, if I'm in charge of a room, I often want to do very weird and specific splits to different devices.
Well, I'm not saying remove the headphone hole. Right? It's just...
But no, I agree with you 100%.
In the vast majority of cases...
In the modern world, there's no reason to have these separate audio and video chains, because very rarely do you want one and not the other.
Plus if it's a fancy room, right, that HDMI cable is not going to go directly into the projector, sending its audio into the projector, which is really dumb. It's going to send it into some sort of room mixing machine. And then it's going to forward the video to the projector.
We were
and then
spoiled.
It's going to forward the audio to the speaker system.
By RIT. To this day, when I give a presentation somewhere, nobody has it set up like RIT did.
No, not at all.
Every room, the wall jacks, the podiums.
But yeah, more laptops should all have HDMI or mini HDMI, and they should come with the appropriate adapters to go to VGA because it's still necessary. And then if you set up projectors in conference rooms, make sure to provide multiple different ways to connect so that people will use, the one that is the best. And they won't, if people see that the HDMI cable fits, they're going to choose that over the VGA, which requires screwing in and is all kind of funky.
I actually have a non-screwing VGA cable that has little clips that go like a kunk.
Interesting.
Yeah. So anyway, things of the day.
So check it out. It's hockey season.
Hockey!
So it's about time to do some hockey things today, as we want to do.
As I recall, we have had multiple hockey fight weeks in the past.
I think we only had one hockey fight week.
Hockey fight month?
This is a pretty good shtick, right? This guy, I'm not even sure what league this is. It's some minor league. Not too many spectators.
Hockey league.
All right. But this dude, he picks up the puck on his stick, something pretty much any hockey player can do, when he's behind the net, and he pretty much plunks it onto the goalie's head, and then it bounces off the back of the goalie's head and into the goal.
Brilliant.
This would not work in, more professional leagues because...
Someone would have hit him.
If you notice, there was a guy standing right there, basically watching him do it. In the NHL, the guy would have just hit his stick and taken the puck, right? So this only works because it's amateur hour, but it's still pretty awesome, right? It's one of those moves where you're like, oh, snap.
Kind of like the Little League football trick plays.
Exactly.
Or the kids stealing home plate.
Exactly.
I love that.
Love that shit.
So I don't have a video or anything. I'm going to try to not use college humor, cop-outs for a while, but I wanted to use this on a Tuesday, but I figured
I haven't used college humor in forever. This is the first time in a long time.
But basically, this is an opinion piece on the New York Times, whatever, by David Brooks, but it's called The Triumph of Hope Over Self-Interest.
Uh-huh.
And it's an interesting article that, if you boil it down, is basically Why do poor people vote to give rich people more money?
Mm-hmm.
And the statistic is really interesting. I actually want to use this the next time we do a game theory panel. This statistic is pretty awesome.
Are there studies to back up whatever hypothesis this guy is presenting here?
There's one study and then a couple of other kind of tentatively linked to studies.
I think we could actually probably study this psychological phenomena with some sort of game.
He makes some interesting points that if you notice, and this is all just conjecture, the people who tend to vote against tax increases for the wealthy, even though they're poor, tend to live in less affluent areas where they feel like they're richer. They feel like they have more money when actually they're, in the bottom 50%.
Mm-hmm.
So the interesting statistic is that, and this was from 2000, and apparently it's worse now. I'm trying to find the more recent study. It's behind a paywall. They asked people, one, if they believe that they are in the top 1% of wage earners. 19% of Americans think they are the richest 1%.
Oh, boy.
I thought it'd be like 5%,
Whoa.
6%. No, 19% of Americans.
Do they know that the top 1% of America has like 25% of the wealth?
So, a further 20% expect realistically that in their lifetime, they will be in the top 1% if they aren't already.
No, you're not. If you're not in the 1%, the odds of you being in the 1% are 1%, less than 1%.
39% of people think they're rich, and as a result, think that the rich shouldn't be taxed, when in actuality, they're some of the poorest.
Uh-huh.
And it's an interesting article.
So that's the actual study behind those numbers.
Yeah, those numbers are a post-election survey in 2000.
Oh, okay. Wow.
I would love to see today's data.
I would love to see today's data as well.
Of course, the economy got bad, so maybe people will be like, oh, I'm not rich anymore.
Yeah,
hard to say.
My house went under.
So I'm going to try to find some more data, but it's an interesting article.
I would be very surprised if there's any homeless people who are not also crazy people who said, I'm in the richest 1%. You don't even have a house, dude. I mean...
but he doesn't have a phone, so he's not going to get polled.
It's true.
But this is an example, Monday people can talk about this a lot, of game theory. Game theory perfectly models the behavior of rational actors.
That's what I was just going to say. We need to study this with a game.
Yes.
We need to have a game where, we make people think.
A game where there's taxes and you have to vote on the taxes. Straight up.
You vote on the taxes for the next turn.
Yeah.
But you get taxed this turn based on the taxes.
I notice you're not voting for the tax increase. Anything you care to share?
I'm in the top, 20%.
It's an interesting article. I thought I'd do something more erudite than a guy getting hit in the nuts.
All right. Meta moments?
Meta moment. We're going to be at MagFest doing 3 panels, not simultaneously.
That's good.
One is our panel, and then we're also going to sit on 2 of the Mag 9 gaming intellectual panels. I think it's technical changes in game design and achievements in metagaming.
Yeah, I wonder how those are going to go.
I think they'll be interesting. Everyone else on the Mag 9 seems intelligent about games, and we were encouraged to disagree. I don't know if you read that email. They're like, I would hope that you will disagree with each other forthwith in order to make the panels interesting and not just yes man fests.
Uh-huh.
I plan to disagree with people.
Yeah, that's going to go well. The book club book is Hyperspace, right?
Michio Kaku's Hyperspace.
Oh, snap.
The last book club book was World War Z. You can listen to our show from last week. We also have a book club book site. I don't think we put it up yet.
No, I gotta work on that.
Okay, it's almost done. I did all the data entry.
All right, did we add World War Z?
No, that's your book.
Okay.
Gotta add your own books from now on.
All right, I'll add it. And then...
we're gonna be at PAX East. We're gonna be at, Anime Boston, all those other conventions, Zenkai-Con. We're not gonna be at Katsucon, which only comes up because someone emailed us asking about Katsucon panels. We quit that staff like a year and a half ago.
Many years ago.
2 years ago.
You can buy T-shirts,
Geeknights T-shirts, the original series, are actually selling out pretty quick. We have very few left.
And then, you got to buy them all before you get more, so... and we have a Counter-Strike server?
Yes, cs.frontrowcrew.com.
Did you test if that works?
Yes, it does.
Okay.
Also, geeknights.dinedns.com, also the IP address in the forums. It's currently, it might go down tonight because I got to put the computer I built back together. But... we're going to start hosting. This is kind of a test, and it seems to be going well. I'm going to try to host a lot more game and file and servers for you people because I got crazy FiOS.
And someone in the forum is running a Minecraft server. It's actually they're having a second go of it.
Yes, there's Praetoria, which they built.
Well, no, I think they have another one now.
Yeah, now it's Secondus.
Okay, so if you want to play Minecraft with people,
join the Geeknights forums.
Join the forum, and I guess if you fuck around, they'll ban you. We have nothing to do with that. It's unofficial. It's not. It's not officially endorsed.
It is unofficial, but it is endorsed. As in, I endorse it.
All right. Well, they have one.
I guess the gist of this is that we have a lot of listeners who, kind of shy away from all the community around Geeknights, but really, I think the community around the Front Row Crew and Geeknights is stronger than Geeknights itself.
If you listen to this show every day, sir, you don't want to connect with the other people who do the same thing.
In fact, the people
there's only very few people out of the 7 billion people on Earth. There's a ridiculously small percentage of people who listen to this show with any frequency. So if you're doing that, and there are other people who are doing that, those are probably people who are on Earth have more in common with you than any other peoples on Earth, and you probably would, want to connect with those people.
It is telling that many people who don't listen to podcasts anymore. I don't really listen to podcasts.
No.
They go to our panels at cons and everything, but they hang out in the forums to this day because the forum community is kind of an independent body.
Yeah.
And it's not scary like the Penny Arcade forums. It's legit.
Yep. All right.
So, Abstraction.
Yeah. We sort of came up with this idea. Who knows how it'll go.
Scott didn't want to talk about home networking.
No, we already did that.
We talked about our own home network.
That's the same thing.
I don't know. Would you guys want to hear about port forwarding and all that?
Okay, whatever.
Listeners, back me up.
Yeah, they want to hear about anything. They'll take any show they can get.
No, they won't. They want a zombie show and a food show.
Yeah.
And a port forwarding home networking show.
So anyway, I wanted to talk about abstraction because it relates to the networking situation, right?
It's also widely misunderstood.
And it's also pretty much what, the core concept of pretty much modern computing for anything, beyond a user level, right? Anything deeper than a user level. You have to understand what abstraction is, and you have to be able to recognize layers of abstraction and the connections between them. And you have to know what abstraction means. Right? And we also use this term a lot when talking about board games and RPGs, where it means the exact same thing.
It always amazes me in my professional career. I run into people who ostensibly went to computer school. They learned the computers. And it's not that they don't know some particular thing, like how to do abstractions or instances or interfaces or whatever in a particular language or the OSI model, but they just never learn coding enough to know the fundamentals of how to write code or how to... I've got to think, they don't understand abstraction, which is the core of modern coding.
Right, so to give you an idea of what abstraction is, right, let's talk about, the OSI model of networking, which is something you should learn also. So we're going to give you 2 birds for 1 stone here.
If you learn Cisco, you probably think there are 5, but technically there are 7 layers.
Well, the thing is, the top layer is the application layer, and the thing nowadays... The application layer can have multiple application layers and often does, so shit gets crazy. But there's really only 7 layers, in the classical...
Do you remember them?
Academic. I'm going to look them up on the internet right
really?
now. I remember most of them.
Physical data link network, transport, session, presentation application, because presentation's all the encryption and stuff.
Yep.
Took me a while. See, the thing is, the OSI model, it's funny because it's an abstraction and it's very important, and yet TCP/IP, which is kind of based on the OSI model, is not 7 layers. They actually only break down to 5 layers, and most people only know that.
Yep. But anyway, what an abstraction layer is, think of it like a cake, right? You have a layer cake, where each layer rests upon the layer below it. So each layer is a layer of abstraction, and what it does is basically it allows you to interact with a technology or a system, right, while hiding everything that can be hidden and only, fulfilling certain functions. For example, think about your car that you drive, right? When you're driving this car, you're stepping on a gas pedal and a brake, and you're spinning a wheel.
The gas pedal abstracts a throttle mechanism that is surprisingly complex.
Yeah, so inside the car, what happens when you step on the gas pedal is this ludicrously complex system, right?
Well, it depends. In older cars, like my car,
well, it's
there's
a ridiculously
wire.
simple system.
There's a wire that just opens or closes a hole.
Yeah, pretty much. But
opens or closes more or less. Doesn't completely close.
In many cars nowadays, they'll actually, stepping on the gas pedal will go to a computer, which is calibrated to think, okay, stepped on it this much, so he wants to go this much faster, and the automatic transmission might change gears.
And then when he steps
depending
off,
on how quickly you stepped on it.
When you step off, it'll keep going at full speed until it crashes and you sue somebody.
Yeah, there's various various things that go on just from stepping on a pedal, right? So this simple mechanism of pedal goes up, pedal goes down is abstracting this complex system of pistons spinning and going up and down and, gas, moving around and air intakes opening up.
We got technical people. I mean, let's talk about accessing web page. I got Firefox open right now.
All right.
So Firefox is displaying a web page. I'm communicating with something. Say I connect to Scott's server over at his house. Firefox doesn't know anything about the voltages on the wire.
That's for sure.
It doesn't even know anything about MAC addresses or data links. In fact, there's stuff at both ends because you kind of have to go down through the layers of abstraction all the way to the bottom and then all the way back up to the top again. So basically, you've got all these layers. If Firefox at the top is my application layer and I'm connecting to Apache on Scott's server, which is an application in and of itself, the application only knows that it's talking to another application.
Yeah, I mean, when let's say I was going to write my own web browser in C, let's say, right? C knows how to work a computer, right? So in C, I would be doing things like moving bits around in memory and flipping transistors and moving data between RAM and the CPU and, writing and reading data from input-output devices, right? But I don't have to set the voltage on this pin to 6 volts. You never had to write that because that is something that is hidden from you on the layer that you are working on. Right? So in order to do networking on the internet, as the most of the networking that you're going to do in your life, there are actually 7 different layers of this kind of abstraction going on, right? The bottom layer, of course, being electricities.
Or electrons. Well, that's the same thing. Or photons is what I meant to say.
Oh, photons. Yes, it could be optical. You are correct. It's basically the electricity, the lights, the whatever, some sort of physical hardware. It could actually be like somebody's hand taking up, a plastic tube and moving the plastic tube from one chute to another chute, and then the tube goes flying away, right? Whatever the physical thing is that makes the data move is the bottom layer.
So a simple example. You just have 2 computers, they're on a local network, you just want to have them talk to each other directly. So the computers at the lowest level, layer 2, the so-called data link layer, they know, they have an abstraction of the physical layer. They know something like send data to this address on the network, in quotes. It knows there is the network. I can send stuff to it.
Yep.
And I can get stuff from it. That's all it needs to know.
Yep.
And then, every layer up only needs to know the layer underneath it.
Yep, so the layer 3 is like the network layer, right? And that's where you start getting the switching and the routing going on, If you just have
That's IP.
Yeah.
A data link, MAC addresses. So, I connect out, so IP address. And ports, that's transport layer. So I connect to port 80, that's the transport layer. That says, what am I connecting to? How am I connecting? TCP, UDP, all that stuff. And then, so where am I connecting? The next layer down, that's like your address, the IP address. And then once you get through the switches and routers, your MAC address doesn't travel all the way through. MAC addresses is just local computers next to each other talking.
Mm-hmm. Actually, I don't think a lot of people understand how MAC addresses work. We should like.
All right,
we can cover that very quickly.
Well, what about it? I mean, it's actually not a quick thing to cover if they don't actually know how it works.
No, that's what I'm saying. Is that it's pretty quick, right? It's basically when you plug your computer in with a wire, right, on a LAN or with a hub.
This ought to be good.
Okay. Basically, what happens is if I want to send a packet from my computer to Rim's computer, right? And there's 10 computers on this network, and they all just have wires going into a hub. So how does my packet get from my computer to Rim's computer? A hub doesn't know anything. All a hub does is take every packet going in and send it out to everybody. All right? It doesn't know shit. So everybody sees the exact same thing. So how do I talk to just Rim without talking to anyone else?
All right, we can go up a level. So you know my IP address.
Okay.
All right, so what does it do?
Okay, so
I'm just curious here how much you know this.
How much I know this?
Yeah.
All right. So I decide that I'm going to send, something to Rim's IP address. So first, my computer looks at its network configuration. It looks at the subnet mask, right? And if the IP address is in the subnet mask, then it knows that Rim is on the local network and he is not on a remote network.
That's a roundabout. Yeah, that's kind of true.
That is correct, yes.
Well, it more has to do with whether or not you have a specific route, at a higher level part of the protocol.
I was about to say, if the IP address is not in the subnet mask, then it will look at the default gateway.
Yeah, but then it still does the same thing because if you connect to the default gateway, the router, the router that you've got connecting your computers to the internet, listeners, You connect to that IP, and then that basically makes its own connection out to whatever you're doing.
Yep. But anyway, so let's say I'm going to send the packet to Rim. He's in the local network, right? So he's within the subnet mask.
What's the first thing that comes out of your computer?
The very first thing?
When you're trying to send data to me on the local network, and all you know is my IP.
I believe it would be the ARP.
Yes.
The ARP is the first thing. So
you know what that stands for?
I have no clue.
Address Resolution Protocol.
All righty.
It's actually pretty straightforward.
So the ARP goes out, and it says, hey, I'm looking for this address. And then Rim's computer would say, hey, that's me. I got that address. So I go, aha, I see Rim over there.
Well, I don't just say I've got that address. I say I own that MAC address, which it figures this out on the physical level with a bit mask, and then it responds and says, not only do I know, is that me, here is my MAC address. And then Scott's computer says, okay, and caches that, and then sends to the IP address of me the actual data he wanted to send, but encapsulated in that, that IP packet, that data is itself encapsulated into, I don't want to get into the technical details of frames and windows and everything, but it's basically encapsulated in something that says, deliver me to this MAC address. And the thing that delivers it, which is just the wire, doesn't know shit about IP addresses. All it knows is it takes it and it sends it to, a switch, that MAC address. Or if it's a hub, everybody.
Yep. So that's how that works, right?
So
you can see how these layers, right? So if I'm working with IP addresses, I don't have to think about the MAC addresses because that's just, I'm one layer above that shit. If I'm working with MAC addresses, I don't have to think about electricity, right? The electricity is just taken care of.
I guess a simple way to explain it, the OSI model, abstracting this out is the same as encapsulation. The physical layer is like an envelope that holds everything above it. And inside of that, there's an envelope of the data link. And inside of that, there's an envelope with the network. And you open all the envelopes and seal all the envelopes up and down the chain at both ends.
Yeah, imagine if there was a post office. Well, there is a post office, right? And they have the address of your house, but then the envelope gets to your house, and it says, apartment 1A in this building. But then you open the envelope, and it says, deliver to the desk. So now you've got an address within an address. You got to go find that desk.
Yo, dog, I heard you liked addresses.
See, so then you bring the envelope to that desk, and the guy at the desk opens the envelope, and it says, this will be delivered to drawer number 3 in this desk. So now he has to put it in drawer number 3.
Who addresses an envelope like that?
And then inside...
If I got an envelope that was like, your right front pocket...
Right, so then in drawer number 3, there's a midget, and that midget opens up the envelope, and it says, give it to the third dust mite from the left, and right? So that's how this works.
I apologize that we keep saying the same thing over and over again, but I realize every time I've ever taught this, I've actually taught classes on this stuff, mostly to like high school kids back when I was at IBM.
Mm-hmm.
I always had diagrams that I pointed at and examples.
Plus, even if you explain it to people, they still don't sort of understand. And the thing is, this is not just networking, right? Pretty much everything you do in computing follows this model, right? So I'm a programmer, right? So I'm programming. I don't have to think about the transistors flipping anymore. I mean, I could if I was programming in Altair, right? But I'm not. So on top of that, you've got the machine, the assembly language in the CPU.
But Scott, what if you were writing a program that itself simulates the physical interactions of transistors, and then you use those transistors to build the OSI model again on top of it?
Or I could even do some FPGA, and then shit gets real crazy.
Oh, mans.
Right. So, and then on top of that, you've got a programming language like C, where C, abstracts away a lot of the machine language, but it doesn't abstract away things like memory management, right? But then you got a programming language like Java or Python or Ruby, which abstracts, it's even a layer on top of C, where it abstracts away the memory management. It's just a garbage collector and those sorts of things. You don't have to think about the RAM anymore. All you have to think about is, just these concepts of variables and, moving data around. And you don't even have to really think about the hardware in the computer at all.
In a way.
And then on top of that, you might be using an application that, for example, something like Game Maker, right? Game Maker is a program that is written in another programming language. You can use it to make a game, right, with just a GUI by clicking on pictures. Or Flash, you can do the same thing, right? And then Flash has ActionScript, which is then going to layer on top.
When I was really young, like way young, and I was playing with QBasic on the school's computer,
yep.
I had this sudden revelation when I realized that the interpreter I was using was written in a language.
Yep.
That it was I suddenly was like, wait a minute.
Yep.
What's at the bottom?
Yep.
And that started my long road to where I am now.
Yeah, I mean, if you want to, I mean, this is the one thing that confused me for the longest time.
It's turtles all the way down.
Right, it is turtles all the way down. Is how do you translate from, how do you get to the difference between typing in letters down to the electrons? It seems like there's some sort of barrier in between. How does that shit work?
That's assembly.
Right? And pretty much the way it works is, this assembly language. And an assembly language, if you look at assembly language, the way people type it, it looks like, move L %RDB space, %RDQ or
It's
something.
basically just binary math done with wires.
That's what it looks like when you're typing it in. But the fact is that directly translates to something like 00101010, right? And that 0 and 1 0 and 0 literally translates to 0, turn this wire, no electricity. 1, this wire has electricity. 0, this wire does not have electricity, right? So
now think about that.
All those pins on the bottom of your CPU are going to have electricity going into them or out or not.
When you're writing applications, it is no different than physically controlling machines. You are physically controlling real moving things with mass.
Right, so if you have a 64-bit processor, that means that the instructions are 64 bits. So imagine you have 64 on and off switches in front of you.
That's it.
Yeah, and so you turn them on and off, and there's 2 to the power of 64 different combinations of ways you can turn them on and off, which is a lot. It's bajillions, all right? And that is the number of possible instructions there could be. Obviously, they don't actually have that many instructions because you don't need that many, right? But that's how many instructions there could be. And so multiply might be 0, 0, 0, 0, 1, 2, 1, 0, right? Whatever. 64 ones and zeros, one combination of them is multiply. So then after that, you got to say, well, which numbers do you want to multiply? So there's 2 more 64-bit numbers, which are in binary. And then so if you send all those bits into the CPU, out comes the other end, the multiplied, the 2 numbers, another 64-bit number, which is the multiplied number is the result.
That was we abstract all that.
Yeah.
We abstract all that because it's boring.
You don't have to remember, right, what the bits are to actually, tell an x86 CPU to multiply 2 numbers by each other.
To conceptualize it a little more simply, like to back up even, an abstraction is like an analogy, and note how I used a simile.
Oh.
But in that, when you abstract something, like say I'm trying to program a Scott simulator,
Okay.
I'm going to abstract Scott in a way.
Yeah, he's not going to program like the lungs breathing. That's not the point of the Scott simulator.
Yeah, now I might make a very detailed abstraction. It might approach a real Scott, but much like analogies, if your analogy never breaks down, it is not an analogy. It is the thing. If I'm able to perfectly emulate Scott, absolutely, actually
every
perfectly,
single atomic particle,
then I have made a Scott.
Yep.
Straight up. There's no difference between that Scott and this Scott.
Mm-hmm.
Except locality, but that's, yeah, you get the point. So say I want to write a ticketing system. I want to track problems. I'm abstracting problems. A lot of people who just get into programming don't actually abstract enough. They think too close, like, all right, I'm making a ticket. Tickets are like this, and they kind of work through, when really they should back up and say, what am I trying to accomplish? And then abstract that. All right, what are the basic components of a problem? Well, a problem has a person who opened the problem. It has a solution. It has the steps I took along the way to fix it. It has the money it cost, the time I spent on it, all these things. And that is abstraction. You're abstracting a problem into something that you can then do something with.
Yeah, I mean, because the reason that we're, abstraction is progress, right, is because, number one, we've solved most of the problems of the world, right, especially on low levels, right? For example, we've solved the problem of HTTP, right? I mean, there are perfect implementations of HTTP stacks. They're effectively perfect implementations of TCP/IP stacks. You're not going to write a better TCP/IP stack, or you're not going to write a better HTTP client or server. It's not likely, right? What you want to write is a website. Technically, you could write a website in assembly language, right? You would have to write a TCP/IP stack. You'd have to write, an HTTP client and a server. You would have to write all the memory management. You would have to write an all this stuff you would have to write. Instead, you just want to reuse the stuff that's already been written, and you only want to worry about the problems that you care about. The things that you care about are, what does my website look like, and how does my website work? And if you actually have to rewrite Or think about the electricity on the wire, which is something that's happening when you're visiting a website. While you're making your website, you're never going to solve any website problems. You know, where would Google be if they actually had to worry about the electricity on the wires directly? Right?
Well, they do because there's a lot of it and it costs a lot of money.
I'm just saying if they had to worry about that from the beginning. They only wanted to solve the problem of searching. If they had to solve the problem of electricity on a wire before they could solve the problem of searching, they never would have solved the problem of searching.
Of course,
right?
this gets into even not just abstraction, but also, standing on the shoulders of giants, that every human alive today, at least if you live in a society that is free and you are not disadvantaged due to the fact that we're not, as humans, that good at this stuff yet, society and being nice to each other and everything, you basically have this huge set of resources that are the constituent knowledge of everyone that came before. And most of it's on the internet.
Yep.
So you start at this high level and you can pick very high level problems to solve because you're not worried about instantiating food on a given day.
It's like, all right, think about something that's more accessible to computers, right? Let's say you're a chef, right? Imagine if you wanted to become a chef. You had to reinvent knives and knife sharpening. You had to reinvent forging, right? You had to reinvent mining of metals. You had to reinvent, the fire. You had to reinvent ovens. You had to reinvent...
I like how fire gets a definite article.
Right, I know.
You go too far.
I know.
You play God.
Imagine if you had to reinvent all those things and build your own oven.
Oh, you mean like
forge.
You mean like if a biologist had to reinvent calculus?
Yeah. or make your own knives. Well, someone might really like to do that, and I say go for it. That's awesome, right?
It's not going to help you cut a tomato better.
Right. If your job is chef, you really want to just think about the recipe and the preparation of the food to make it as good as possible.
It also, to use a less, silly example, because this is kind of silly to think, all right, I want to be a chef, I want to do all this. What if you're a chef and you really focus on cutting the tomatoes into absolute perfect cubes? When really, that's not the important part. That's not the part that you want to get to.
It might be, depending on what you're doing, but it's rarely.
Most likely not. We use this a lot in the Tuesday shows and in our lectures on gaming, role-playing games. A lot of people who get sick of Dungeons & Dragons get sick of it because it doesn't abstract the boring shit.
Yep.
And games like Burning Wheel, they instead of saying, I have 58 Electrum pieces and 1 Platinum piece and 5 rubies, you say, I have a level 4 money.
Yep.
And you abstract all that haggling and buying stuff and keeping track to, I rolled the dice once. Yes, I can afford the sword. No, I can't afford the sword.
Yep.
And you get to skip the boring part of buying the sword and get to the awesome part of using the sword
and if you
on someone.
If you want to haggle, you make it 1 easier or 1 point harder to succeed at that roll of the dice. Basically, you come up with some system that is not the original system because it was the original. If it was actually money, it wouldn't be an analogy. It would be the actual thing, right? So you come up with something that is simpler.
There's a role-playing game.
What?
It's designed to use real money between the game master and the players.
What are you role-playing as? Stockbrokers?
Fuck if I know.
Merchants?
But we can make some money with this. That's it.
We'll have tournaments at PAX.
Yeah.
Yeah.
I'm sure that the staff of the Penny
all
Arcade Expo...
player versus environment, of course.
Of course.
Of course.
+1 sword, eh?
Actually, a poker-based PvP RPG with real money. Has it?
Not with real money, but it's been done.
I'm saying with real money.
Yeah.
Take a little luck out of it, add a little role-playing to it.
We should write the rules and just put something online and watch the crazy chaos that's going to ensue.
No, we should make a website where you can play it to avoid all the regulations about online poker because it's not poker.
Nah.
It's role-playing.
And all we do, here's the brilliant part, all you do...
And here's how...
Scott, Lizzie, hear me out. You keep the books of who has how much money in each local gaming group. You keep it on the server for them. You're not handling money. You're just handling fake money. And you tell people you shouldn't use this to determine how much money to give your friends and who owes you how much money. And they will anyway.
Oh, I was thinking that everyone would send you a money, which would be the monthly fee. And then you would give out prizes.
Nah, giving out prizes is a thorny ground. You give out virtual fucking prizes because fuck them. Brilliant.
The prizes never add
up. Scott, abstract prizes.
Yes, here's a picture of a present.
Here's a picture of a $20 bill.
Here's a picture of Andrew Jackson.
In fact, it's the picture. It
really is a photo of Andrew Jackson. Here you go.
So
no, there's no numbers next to him. It's just him.
If everything we said doesn't make sense, just follow the Wikipedia link that I'm going to put. I'm sure the Wikipedia page... Yes, the Wikipedia page has a picture of the OSI model.
Yeah, but I mean, this concept of abstraction is pretty much the key and core concept to modern computing, for any, whether you're IT, whether you're CS, even if you're in, I mean, like, think about biologists, think about biology. Technically, there's physics going on way down there,
Yeah, biology is just abstracted physics.
Right, and then it's also abstracted
Take that,
chemistry,
biologists.
too, everything is abstraction, right? You want to think about a problem on a higher abstraction level, right, to figure it out, because if you actually had to think about what every freaking electron and subatomic particle was doing when DNA was restructuring itself,
now you might need to zoom in.
You would never get it all.
You might have a problem where you do have to zoom in way low, and some things can't be that abstracted.
That is
true.
But
that's not where you should start. I mean, I realize, as we won't talk about inheritance or anything, or classes, or abstract classes.
Well, you think about it, I could write a program in Python, and it might have a problem where there's too much memory. It's using all the memory on the computer. And I might have to look one level lower, on the abstraction, to see where the problem is if I can't find the problem in the Python code itself. That happens pretty often. But you don't start, that's not an excuse or a good reason to throw away, this higher level abstraction and write everything in C, because then everything is going to be a pain in the ass.
Or even within a simple application. Say you're simulating, firemen. So you write like the fireman class, and then you inherit down and make very specific implementations of fireman. You don't start with the very specific implementations when you're writing code, because then when you're trying to work up to the more abstract stuff, you're basically guaranteed to have made a terrible mistake.
Yeah. All right. If you don't get it by now, and, it's just real important. So we want to give a lot of examples, and we don't have any visuals, so we want to give a lot of examples.
How can she? I wanted to say, how can she something, but I got nothing here.
No, I didn't give you any opportunities.
It's not the right time for that. I got to save it.
You are who I thought you were.
This has been Geek Nights with Rim and Scott. Special thanks to DJ Pretzel for the opening music, Kat Lee for web design, and Brando K for the logos.
Be sure to visit our website at frontrowcrew.com for show notes, discussion, news, and more.
Remember, Geek Nights is not one, but 4 different shows. Sci-Tech Mondays, Gaming Tuesdays, Anime Comic Wednesdays, and Indiscriminate Thursdays.
Geek Nights is distributed under a Creative Commons Attribution 3.0 license. Geek Nights is recorded live with no studio and no audience. But unlike those other late shows, it's actually recorded at night.